In this video, we're going to look at topic 76, example 5, using a system to solve an equation. Solve the equation x squared plus 9x minus 5 equals 4 minus 3x by writing a linear quadratic system and using the intersection feature of a graphing calculator to solve it. Okay, so let's do what they tell us to do. There are multiple ways to solve this, but we're going to solve it the way that is suggested. So what I'm going to do here is, since we're looking at a linear quadratic system, the linear side would be this 4 minus 3x, and the quadratic side would be this x squared plus 9x minus 5. So I'm going to rewrite my system as y equals x squared plus 9x minus 5, and y equals 4 minus 3x, which we're allowed to do, don't write so sloppily, 4 minus 3x, right? Yeah. Okay, so we now have our linear system, and quite similar to the problem that we did before, we're going to type these into the calculator to graph them, and then look for some intersection points. The previous problem was an inequality. I'll go back to it real quick. So we're looking for overlapping shared regions. In this one, we're looking at solving an equation, so we are looking for intersection points. Okay, so let's go to y equals. I'm going to color code these, so we'll try to stick with the colors that I've already pre-assigned for them. So the first one we'll type in is 4 minus 3x. And the second one we'll type in the x squared. Oops, wrong button. Just delete that. X squared plus 9x minus 5. Okay, so we have those typed in. Make sure it's typed in correctly. It's probably the most important thing that you can possibly do. And from here, I'm going to hit graph first to see what my graph looks like. So I do see that I have a solution somewhere right in this kind of area here on the graph. Don't quite know where that is. And I'm going to have a solution somewhere on the top left. That's off my window, so it's going to be, I'm going to need to zoom out. All right, so if I do zoom out, I'm going to do a zoom fit actually. So zoom fit, and that didn't help me either. So I'm not going to do that. I'm going to go back to my standard, and what I'm going to do, where are we? I'm just going to go to my table and start plotting some points. So for the blue one, we know that this answer is going to be pretty high. The graph goes up to 70, so this should be a blast. My x values are only up to negative 16, so I'm going to go as far back there as I can. Negative 16 goes with, again, we're looking at the blue one, negative 16 with 52. So let's plot that. That'll be somewhere around there. Okay. Negative 1549. I'm not going to do every single point. So let's say negative 1343, or let's go with negative 12. Negative 1240, that's going to be here. Let's keep going. Negative 8 and 28, that'll be somewhere here. So what I'm looking for here is a ballpark, kind of to get an idea of where this answer might be, is going to, because the calculator ultimately we're using the intersection point. So really we're just trying to get an idea of what this graph looks like. It's not the most fun thing in the world, but we'll be okay. And let's find the last point of 4, negative 8. So 4, negative 8 will be somewhere here. Okay, so this is the line. I'm going to connect these. This is not going to be a perfect line. Remember, we're just estimating where some of these points are. We're not estimating. We're drawing it by hand, so it's not going to be perfect. So now I'm going to do the same thing with the red points, so I can get my quadratic shaped. So again, let's go back as far as we can. That's reasonable. Let's go with negative 1231. Let's see where that lands us. Negative 1231 would be here. So I do need to go a bit further left. So let's go with negative 1465. Okay, negative 1465 would be here. All right, so that's going to be a bit more helpful. Definitely to connect those points, I'll have to cross the graph. All right, so let's go down to negative 8. So negative 8 goes with negative 13. Negative 8, negative 13. Yeah, that's going to be way down here. Again, this is not the most fun process, but we do need to find some solutions to have an idea of, kind of what we're looking at here. If the book decided to give us a better formula, I promise this is a quicker process. Right now, what I'm showing you is almost worst case scenario. So 0, negative 5, that's going to be here. So this is good news. We're now kind of going back up to the right. And let's look at 1. 1 goes with 5, so that's going to be here, which tells me what I need. And let's go with just 4 and 47. We'll end this, make this a little less painful. All right, so from there, I would try as best you can. My AirPods just died. To connect these, hopefully the audio still holds up fairly well. And now we know that our solutions are somewhere around here and somewhere around here. All right, so we're going to look at about, so my window. So now I'm going to go to the graph, and now I'm going to change the window, and I want the x minimum. I'm going to go with negative 16. I'm going to go with the x maximum. This graph shows me I really only need to go up to 4, so let's do that. The x scale, that's not too important, but well, let's just leave it at 1 now and see what happens. The y minimum, we can go down as low as negative 30, and the y maximum, I'm only going to go up to 50 because I know that my solution is going to be below 50. And the same thing, I'm going to leave the y scale alone for now, just leave it at 1. So if I graph this, that'll do. It's not in good perspective, but it's fine, we'll manage it. Now we're looking for intersection points. So this is really the main thing that you need to be able to do here. So all of that work was just to get an idea of what our graph is going to look like. Now, would you actually need to do all these plotted points? No, I know I've kind of droned on a bit about that, but it is important to know how to get a graph from a calculator. So, final step, bear with me. I might have even suggested that you fast forward to this point at a certain point anyway. So let's go with our, we're going to go second, calculate, and then we want to find an intersection point. So that's going to be number 5. First curve, just make sure it's on either the red or the blue line, doesn't matter where. It's on the blue one, so we're going to hit enter. Second curve, make sure it's now on the red line, which it is. So I'm going to hit enter. And now my guess, we want to put this as close to our solution or intersection point as possible. So we're going to put that there. All right, so we're going to hit enter. So the intersection point, intersection point 1 is approximately negative 12.7, I'm just going to go 1 decimal place, and 42.1, which seems accurate. Okay, so we're okay with that. So I'm going to highlight that one in gray. I'm going to get rid of that, and I'm going to change that color. I'm going to change this one to green. So that's our estimated intersection point. We'll get to the actual solution in a second. I need to do a second calc again. Go to intersect again. This time again, make sure it's on one of your curves. So it's on the blue line. I'll hit enter. Second curve, make sure it's on the opposite one, the red line. Enter. And now guess, and it's critical that you have to put that cursor near the intersection point, because if it's not close enough, it's going to give us the point that we already found. So intersection point 2, so let's call this intersection 2, is approximately 0.7 and we'll round out 1.9. Okay, which again makes sense based on our graph, so we're okay with these. So now the actual solutions, so what are the solutions? The solutions are x is approximately negative 12.7 and x is approximately 0.7. All of that work, all of that time, all of me talking on and on and on, just to find those two intersection points. Again, this was kind of a worst case scenario. You could skip a large portion of this if you didn't have to draw a sketch of this. We're trying to draw a sketch, so we wanted to make it as accurate as we could. If you didn't have to draw the sketch, you could have just zoomed out until you found the intersection points, and eventually you would have gotten the answer. I'll apologize on behalf of the book. They should have given you a much more user-friendly problem. Sorry.